And this is a place we do testing. Oh, can you believe that? Someone left banana peels out on the floor. Oh, but the new spot has an arm that it can use to get up when it falls. This robot was scaled to be big enough so it can go up and down stairs, normal stairs, but small enough to be as small as possible. It only weighs 60 pounds. It's all electric. It's got a vision system so it can look at the world around it and figure out where to put its feet. And it's got reflexes and control like the other robots so that it can keep its balance even if it didn't get its perception to work exactly right. Now, we use biological inspiration for some of our work. That's an ordinary chicken who knows how to keep its head stable for a number of reasons. And we programmed, this is called Spot Mini, to be able to do a similar kind of stabilization.
Cool.
Which means that any sensors in the hand, this is the real reason, so you can serve your wine without spilling it. And it also means that you can have a mobile system that's still doing endpoint control and have everything coordinated so that it can think in terms of the task it's doing, which is in that case picking up that can. Now, this isn't perfect yet. It didn't actually supposed to leave the soda with
That was funny.
And we're also doing work on robots that have are bipedal, or more of a human form. This is a second generation Atlas robot that we've been working on. It weighs about 180 pounds and it's just a little bit taller than me. We had a previous one that was a real hulking monster, and we really wanted to get something that was more in the scale of a human. And we've been testing it doing logistics tasks. Here it's handling boxes. It's using its whole body, not only its arms, but its ability to orient its upper body and obviously its legs in order to do these handling tasks. And there's really quite a lot it can do. Here we're sort of testing whether it can operate at roughly human speeds. It's still a little slower than a human, reasonably slower than a human, but we've been working on getting it to go faster and faster and better. Again, one of the themes of this work is to make the robots tolerant of a world that isn't always doing exactly what it thought it was going to do. So here it's been told to pick up that box. It's using its vision system and those markers to figure out where the box is. But then as our engineer gives it a hard time, that guy's known as hockey stick guy around the world. The robot is able to replan, reperceive, and adjust what it's doing. We've been taking it out to various human sites that are designed for humans and testing on stairways, and this is a bar where it's autonomously navigating and avoiding obstacles as it goes through. Here's an experiment with a person and robot task. We actually didn't do any special programming for this, but the force control in the arms make it tolerant of...
Wow, look at that.
And obviously if you have a dog-like robot and a human-like robot, it seems like you should take them out
for a walk.
I'm not sure who was walking home for that. Now everybody thinks we only do legged robots, so no one has seen this. You guys are the first. This is the debut presentation.
Oh wow, look at this.
Of what I think will be a nightmare-inducing robot if you're anything like me.
Oh
but this is an experiment in combining wheels with legs with a very dynamic system that is balancing itself all the time, and it has a lot of knowledge of how to throw its weight around, which it uses to help stabilize itself. Here we're just testing out the various capabilities. This is much more efficient than a legged robot. It can carry a reasonably heavy load on a small footprint, and it's basically an exercise in seeing if we can do something like the humanoid that has less degrees of freedom, eventually could be less expensive, but still have a significant capability. We call this handle because it's supposed to handle objects eventually. Here it's showing off.
Oh, yeah. X Games.
I think I'm probably just about out of time, so I won't go through these other slides. Maybe they'll come up in the discussion. But we brought one of the robots with us today.
Oh, cool.
This is Spot Mini, and this is Seth Davis, the robot handler. And he's driving the robot around with a joystick and a little Xbox controller. The robot's doing all its own control and thinking with onboard computers. All Seth is doing is giving it speed and direction. One of the cool things about this robot is it can walk with a bunch of different gaits. Here it's a walking gait. Here it's doing a pacing gait. Pacing, in an animal, pacing means the legs on the left are together and the legs on the right. Here it's trotting. A robot like this is omnidirectional, which means that you can drive it sideways, fore and aft, turn in place. You want to do tall and short? The controller for this robot is really interesting. I'm not going to talk about it too much now, but later we can tell you more about it. But there's a style of programming called sequential composition, which means that the programmers can work on really narrow functionality and have the pieces go together to enable a very wide range of capability. So the program that made this robot do the various gaits generalizes across walking tall and short and that kind of stuff. The robot has an arm. Some people think it has a head and a neck, but we call it an arm and a hand. It's actually got a sensor in the hand, and a little bit later, you want to do the chicken head thing? We call this the chicken head move, where it's stabilizing the hand while it moves the body. I just realized that, I don't know if it's politically acceptable, but we really should call this motion twerking, I think. It looks a lot like twerking, doesn't it?
Oh, shit.
Let's see, what's next? It's a kind of a show-off robot, so it has some dynamic gaits. Here it's hopping on diagonal legs. It can also jog.
Quieter than the last one.
And you want to pick up the can? So it's going to pick up this can using a semi-autonomous function. Seth's going to get it so that it's closed, and then he's going to look around with a sensor that it's got in the hand, and then pick it up. Now, one of the engineers who worked on the can pickup is a descendant of Singularity in the sense that he's the son of Dan Berry, who is one of your...
Dan's head of robotics division at SU, or track at SU. Yeah.
And he works at our company. Anything else, Seth? That's it.
Wow. So is Spot Mini going to be here through the lunchtime?
Yes, we're going to have it at lunch, so if you want to watch it more closely, or Seth will show you how to drive it if you want. You can drive it.
How cool is that, guys, huh?